So what we have here is a demonstration of how buoyancy generation in a fluid can generate a circulation. And it has an analogy to the sea breeze that we're going to talk about in class. And so we're just going to go ahead and describe what's in here. So right over here, we have a heater. And over here, we have a cold spot. This is water in there, and the staff at the prep room here have put some little aluminum particles into the fluid so that you can visualize what's happening. What you can see is that over the heater, you're generating some buoyancy. That's because the water is warming up, it's becoming less dense, and the water to the cold side of it is basically pushing in under it and generating this circulation. You'll notice a number of interesting things about it. One of the things you notice is that where the buoyancy is being generated, you see a lot of small-scale structure. And that's very typical for generating buoyancy in a fluid. So these are basically like boundary layer eddies, which we'll talk about in the class as well. And you can see that the fluid is then rises up as the cold fluid comes in and displaces the warm fluid over the heater. And then it reaches the top of the tank, and it drifts over toward the cold side. Then when you see where it comes down, where the fluid comes down, you don't see these kind of boiling small-scale eddies. It kind of spreads out, it gets kind of lazy, and it subsides in a very kind of general way, and that's because it's cooling in a very general sort of way. It is generating some negative buoyancy, but the generation of buoyancy is very diffuse. It's downward net force, and you see this very diffuse flow going from the cold side to the warm side until you once again have the cold fluid displacing the warm fluid as it rises up over the heater.
This water boiling, the heat of the fire, and cooking on the skillet are all examples of heat transfer. In simple terms, heat is the transfer of energy from objects of different temperatures. As objects warm up or cool down, their kinetic energy changes. Kinetic energy is the energy of motion. Temperature is a measure of the average kinetic energy of the particles in an object. As temperature increases, the energy of motion increases. As the water warms up and the temperature increases, you can see an increase in the movement. Heat can be transferred in at least 3 ways: conduction, convection, and radiation. Conduction is a process in which the transfer of heat takes place between objects by direct contact. It is most often associated with solids. The key to conduction is direct contact. The heat of the pan is transferred to the mini pizzas. The energy of the frying pan is transferred to the eggs. Notice that they are in direct contact. Convection is heat transfer by the movement of a fluid such as air or water when the heated fluid is caused to move away from the source of heat, carrying the energy with it. It occurs due to density. Lava lamps are examples of convection. As the liquid is heated, it rises and falls as it heats and cools. As the paper burns, the air is heated up and begins to rise. The burning paper is swept up in the convection current, cools, and falls back down. These beans are another example of convection. As the beans warm up, they rise and then cool and fall back down, and repeat this over and over again. Radiation heat is transmitted without any physical contact between objects. Watch how the temperature of the lamp is transferred to the thermometer without touching it. These alligators and lizards use radiation from the sun to warm their bodies. If you'd like to know more about heat transfer and conduction, convection, and radiation, this playlist will help. And as always, thanks for watching. And Moo Moo Math uploads a new math and science video every day. Please subscribe and share.